Okay, so what I'm trying to do here is I want to see if I can make the connection between these four things and the graph. So the first one is f of 4. Well, that's simply the y value when x is equal to 4. So right here, this would be a f of 4, just that point. Okay. Then f of 4 minus f of 2, that's again a y value, but that's the difference. That's the difference of two y values. So if I'm going to describe that right here, that's going to be f of 4, which is this guy, minus f of 2, which is right here. So this distance from this point to this point, the vertical distance, this is b. That's f of 4 minus f of 2. Okay. Now, this guy, f of 4 minus f of 2 over 2, this, you might notice, this is the average rate of change, right? This is the average rate of change, and also known as the graphically slope of the secant line. Okay, so if I'm going to graph that, so this is basically the secant line between 2 and 4. So right here, if I draw the line that connects those two, that's C. And then last but certainly not least, this is the derivative, f prime at 2. So this is going to be the slope of the tangent line exactly at the point at x equals to 2. So if you draw the tangent line right here, that would be the last one, D. Okay, so we've got this, generic function here without any numbers, and we're trying to figure out all these different things about the function and its derivative. So the idea is to make sure that we can differentiate between the function, the values of the function, and the values of its derivative by looking at the graph. Okay, so we want to first find which one of the x values, where is f of x the greatest. So this is, when we're looking at f of x, that means we're looking at the y values. So this is asking, okay, where is the y value the greatest? Well, that would be right here. This would be A. Now, where is f of x the least? Now, we can see from looking at the graph that it's the least right here. But what we're doing is we're looking at only these 1, 2, 3, 4, 5, 6 choices. So out of these 6 choices, it's the least at point D. Because that's the least y value. Now let's just make it clear, the function isn't the least here, just out of those choices it's the least here. It's really the least right here at this point. Okay, so out of these choices, where is f prime of x the greatest? Let me change the color. Let's see. Okay, where is f prime of x the greatest? So what I'm looking for is the steepest tangent line, because the derivative graphically tells me the slope of the tangent line. So if I take a look at these points and I go, okay, where is it the steepest? I would have to say that it would be right here at E. Because if you look at it, this is right there, E. And that makes sense because this is, remember, called the inflection point. Okay. So then, where's f prime of x the least? Okay, now, here we've got to be a little careful because you might be thinking, well, the least, that that would be where it's 0. But remember, it's what we mean here by the least would be the most negative, because of course if it's less than 0, well then the slope of the tangent line is going to start being negative. So when we say the least, we're looking for, so here it's, for example, right here it's 0 because the slope of the tangent line is 0. But it's less, for example, right here at C, because right here at C it's actually downward sloping, so it's going to be negative. And this is actually the only point where it's negative. So out of these choices, C is going to be the spot where f prime of x is the least. Okay, and then where is the derivative equal to 0? Out of these choices, it would have to be right here at point f, because the slope of the tangent line is 0. Now, of course, there's also this point, and there's also this point where it's 0, but out of these choices, it would be f.